So you see a change. Sales are up, clicks on your website are up. The big question is that difference real? Or is it just random luck? This is probably one of the most crucial questions you can ask when you're looking at your data. And today, we're going to figure out exactly how to get the answer.
All right, welcome everyone to the Tao Salon of Statistics. This is a place where we make sense of the world through data. We're going to cut right through all the complexity and just give you the clear, straightforward tools you actually need. So let's dive right in.
Okay, so here it is, the big question we're all trying to solve. You launch a new marketing campaign or you tweak a feature on your app. How in the world do you know if it's actually making a difference? How can you be sure you're seeing a real effect and not just, a total fluke? So let's start with a really common scenario. We're going to look at one single group's average versus some kind of benchmark. A good way to think about this is like checking your team's performance against a target that the whole company is supposed to hit. And the tool we're going to use for this is called the one-sample t-test. Now, don't let the name scare you. Its job is actually super simple. It tells you if the average you're looking at is really different from a specific target you already have in mind. Okay, let's make this concrete. Picture this. This year's class of students scored an average of 73.4 on their exams. And let's say the historical average from last year was a solid 70. So we see this, 3.4-point difference. Is that a real improvement, or is it just random noise in the data? Well, the t-test is exactly how we're going to find out. And you know what? Here's the best part. You absolutely do not need to be a statistician to understand these tests. Seriously, you just have to learn to ask two simple but really powerful questions. These two questions are at the heart of pretty much any good data-driven decision. Question number one is this. Is the difference statistically significant? This is where you'll hear people talk about something called the p-value. I like to think of the p-value as a fluke detector. That's all it is. If you get a low p-value, and the magic number is usually 0.05 or less, it's basically shouting at you, hey, this probably isn't a random fluke. It's a really strong signal that you're looking at a real effect. But hold on, just because an effect is real doesn't automatically mean it's important. And that brings us to question number two. Is the difference practically significant? This is where something called effect size is a total game changer. It answers the so what question. It tells you how big the difference is in the real world. You could have a result that's statistically real, but it might be so tiny that it just doesn't matter. Effect size helps you see if the impact is small, medium, or large, big enough to actually care about. Okay, so that's how we handle comparing one group to a standard. Pretty straightforward, right? But what if you need to compare two different groups directly against each other? Well, let's take a look at that. For this, we've actually got two different tools, and it all depends on your setup. Over on the left, we have the paired t-test. This is your go-to when you're measuring the same group twice. Think before and after. A perfect example is checking someone's heart rate, then having them exercise, and then checking it again. Now on the right, we've got the independent t-test. This is for when you have two completely separate, unrelated groups, like comparing the TV habits of men versus women. So, going back to that heart rate example, the before and after one, the p-value came back is less than 0.001. I mean, that is a tiny number. What does that tell us? It tells us that the change in heart rate after exercise was absolutely statistically significant. It was no coincidence at all. Okay, now let's flip to the other example, the one about TV habits. The p-value there, it was 0.682. I mean, that is way, way above our usual cutoff of 0.05. So what does that mean? It means that any little difference we saw in TV time was almost certainly just random chance. There's no real significant difference to see here, folks. All right, so we've got one group down, we've got two groups down. But let's be honest, the real world is often way messier than that, right? What happens when you've got three groups, or four, or maybe even more, and you want to compare them all at the same time? Well, for that situation, we need to bring out the big guns. And that tool is called the one-way Anova. It stands for Analysis of Variance, but let's just call it Anova. Its whole purpose in life is to look at three or more groups and tell you if there's a significant difference hiding somewhere in the mix. Here's a classic example. Let's say we have the final marks for students from three totally different university courses. And the question we want to answer is, did one of these classes do significantly better or worse than the others on average? And this is such a great example of why Anova is so useful. Because if you just eyeball the numbers, you'd say, oh, Look, Unit 2 has an average of 74.85. That's the highest. But is it really higher or just a little bit higher by chance? Well, the Anova test crunches all the numbers and gives us a p-value of 0.764. And since that's a huge number, way over 0.05, the conclusion is clear. Nope. Despite those little differences you see, there's no statistically significant difference between these classes. It's all just random noise.
So, how do we actually take all of this and use it in the real world? Because I want to be really clear, these tests aren't just for some dusty academic paper. They are powerful tools for making smarter decisions in business, in marketing, really in just about anything you do.
It really boils down to this simple 3-step process. First, you've got to choose your tool. Match the test to your question. Are you comparing your new website design to the old one? That's a classic before and after, so you'd grab a paired t-test. Are you testing 5 different ad campaigns against each other? That's a job for Anova. Step 2, you check for significance. Was that lift in sales you saw from your last promotion for real? Or was it just random noise? The p-value gives you the answer. And finally, step 3, you measure the impact. This is so important. Was that increase in user engagement big enough to actually justify what you spent? That's the effect size. It's the bottom line business question.
You know, when you get right down to it, all these fancy-sounding tests, they're just tools. They're tools that help us listen to what our data is trying to tell us. Your data is always speaking. The real challenge, and where the real opportunity is, lies in asking the right questions so you can finally understand what it's saying.